Okay. Kids, are you ready?
No. We'll start when you're ready. Kenzie, can you help us read the title, please?
Graphing cubic functions.
Sorry, graphing cubic functions. Girls? So, the name of our function today is called cubic. The parent function, it's y equals x to the
Third. Okay. So cubic function means the power is 3. Sorry, I'm like losing my voice. I'm getting kind of sick.
the HK form. The HK form is f of x equals, as you can see, it's very similar to the past. It's a times the quantity, x minus h to the third power plus k. If
If the equation that's given to you has a power of 3,
that means the parent function is y equals x to the third. The parent function is always, again, always the same function, except you get rid of all what? You get rid of all what? The parents. Transformation. Okay. So the a is gone, the h is gone, and the k is gone. What's left is the parent. Okay, plain, nice and simple. So example 1. Christian, can you help me read the example 1 instruction?
Identify the third function.
oh, right here, hon. Right here.
Graph the parent function y equals x cubed, then find all the defining characters.
Good.
So the parent function is y equals x to the third. Can you guys see all of these inputs right here? They are exactly the same inputs I've given you in the past. Good. But now we just have to plug in for third power.
So -2 to the third power is what? This one goes to Jake. What's -2 to the third power, Jake? Perfect. But it's not just 8. It is
-8.
-1 to the third power. This one goes to Sophia C. What's -1 to the third power, hon? Not 1. It's what? -1.
Because guys, it's -1 times -1 times -1. So a negative number to an odd power will always be negative. Okay?
0 to the third power, Riley, is 0. Beautiful. 1 to the third power, Mariana, is good. 2 to the third power, Autumn. 2 to the third power is not -8, but +8. So those are the inputs. Let's plot them. -8 is the first output. So -2, go down to -8. Then -1, go to -1. 0, 0, 1 is 1, and 2 is now +8. Is that a straight line? Is that a parabola? Is that a V? No. It's like this. Okay. It's called a cubic.
Now, I normally refer to this as a lazy S-shaped curve. Because an S sort of has a top curve and a bottom roundabout, but because it's lazy, it just didn't want to curve. So I just call it lazy S curve. Okay?
H and K. Curves, H and K for this parent function is good.
Axis of symmetry, class. Axis of symmetry is a line that when you fold it on this line, the left and the right has to be identical as well, or the top and bottom. So is there a line that I can fold so the top and bottom are identical or left and right identical? No.
So for the cubic, there is no such axis of symmetry for now. Okay, so NA. X-intercept Santana for the parent function is? Good. Y-intercept, Emily, Y-intercept is?
0, 0.
Beautiful. What is the domain, Kyler, for our parent? Perfect. What is the range, Chris, for the parent? All reals, you're right. Whoa, okay, sorry. Now, for the cubic, increase and decrease. Remember, increase or decrease is you're going to go to the right. If you go to the right and the y value goes up, then what is that? And then if you go right and the y value goes down, that is? Well, look at this parent. Every step we take to the right, what's happening to the y value? So this parent's always going up. So that means this parent will never decrease. If it goes up all the time, how do we state that interval? Starts where? Negative infinity, and it ends at some positive value infinity. This is not a line, so the rate of change will what? Varies. Now, Brandon, is this function a one-to-one? Yeah. Why is it a one-to-one? If you make a horizontal line test, it will only intersect the graph how many times? Once. So this is definitely a one-to-one. For this particular parent function, do we have a minimum or maximum? No, it goes up forever. That means there's no max, and it goes down forever means there's no min. So min and max are not applicable for our y equals x to the third. All right, transformation refresher. Diego, transformation refresher. If A is negative, how would we state that transformation? Good. Reflect over x-axis. Guys, these transformations will not change at all. It doesn't matter what function we give you. Alyssa, if A is less than a value of 1, like a half, a third, what kind of transformation is that? What kind of compression? What kind of compression? Vertical or horizontal? Vertical. Right. Vertical compression factor of A. If A is 9/10, it's a vertical compression of 9/10. If A is a half, vertical compression of half. If A is bigger than 1, like 10, 11, 100, Devin, what kind of transformation is that? What kind of stretch? Good. Vertical stretch factor of A. Okay. Next year, you'll study horizontal compression and stretches, but this year we only study vertical. Slater, H and K will go what direction?
H will go right or left, and K will go up or down.
Beautiful. So if you have positive H, you go right. If you have negative H, like Slater said, you will go left. If you have positive K, Slater said you go up, and negative K to go downward. Okay. Steps to graph any function, not just y equals x to the third. These are common steps. Ben, can you help me read number 1?
Identify the parent function.
Perfect. You have to see, is it to the third? Is it square? Is it absolute value? Is it a line? Alan, help us with number 2.
The table of values for the parent function. Minimum 3 points, recommended 5.
Perfect. Naomi, number 3.
Identify A, H, and K.
Perfect. Malin, number 4. Good. Hannah, number 5.
Make a new table of the values using the transformation F, x minus h, AF, x plus b.
Okay, this is really scary looking, isn't it? Okay. Can you guys see this? It says here f of x minus h. This says if you have an h value, is it changing the horizontal
or is it changing vertical? Horizontal, because it says x minus h. If you have an a and a k, this is changing your y, your vertical. So you have an a value, you multiply to y, f of x is the same as y. And then if you have a k value, you add or subtract to the y side. Okay. Number 6, Elena, can you help 6? Perfect. And Wyatt, help read 7. Yeah, the table is very common. All right, let's do. Success is if you can finish example 2 and 3. Okay. All right. Olivia, can you help me read the equation of example 2? Perfect. Can you see that there's a 3 power in there? That means the parent function is what? Y equals what? X to the 3rd. Yep. Okay. A, H, and K. Chizuki, what are the values of A, H, and K from our equation? A is? Good. H for our equation is? Good. K is? Perfect. Okay. Now go ahead and find a calculator. Take out your own calculator. If you don't have one, go borrow one of mine. Because I need to teach you how to use your calculator for cubic roots later on today. Go borrow my calculator or have your own. Everyone have a calculator ready to go, please? Yeah, it doesn't matter. Just have one ready to go. All right. So our input for the parent are -2, -1, 0, 1, and 2. Adam, can you give us the 5 outputs for the parent? Beautiful. We have an A value of 1/2. We will use that to transform. Is it X's or Y, Sophia H?
Y.
Good. So 1/2 times Y. Beautiful. We have an H value of 4. Grace, do we transform X's or Y with the H value? Very good. So we will add 4 because it's a positive H. Nathaniel, we have a K value of 3. Do we transform all X's or all Y's with a K? Perfect. So we're going to add 3. Okay. All right, class. Take all the parent X's, transform that. And then once you're done with the X's, take all the parent Y's and transform that. Once you're done with the table, compare your answers. And then Megan, give me all the new X's. Okay? And Sophia, Ed, give me all you new Y's when you're ready. Ready? All 5 inputs for our, new function. What is it? 2, 3, 4, 5, and 6. Thank you. And Sophia, and whenever you're ready for the 5 outputs, hon. -1, 2.5, 3, 2.5 again. Are you sure? It's not a parabola. It's not symmetrical.
Oh.
Yeah, okay, try again. Are the first 2 okay? Yeah. What's the next 3? 5. No? No? It's okay. Take your time. What's this 3rd output? 3, okay. What's the 4th output? 3.5, okay. And then the last output, what is it? 7, perfect. Okay, that's why I always want you guys to compare your points with your neighbors.
All right, let's plot. 2 is now going to go down to -1. Okay, that's my first dot. Positive 3 is now 2.5, so somewhere there. Positive 4 is exactly 3. And then 3.5, and then the next one's all the way to 7. They should look like a U, a V, a line. What is it? A lazy what? A lazy S shape. Okay. You have 3 transformations. Brian, A is a half. What kind of transformation is that? Good. Factor of how much, hon? Good. H is a positive 4, Trevor. What kind of transformation is that?
Positive 4, that would be a move to the right.
Good. Right 4 units. And then K is a positive 3. Hun, what would that be for K being positive 3? Perfect. Beautiful. All right, let's fill out the chart. H and K, Dahlia, what do we fill in for H and K? Good. Okay. Let's look at the graph. Do you think you can have an x-intercept, class? Yeah, can we eyeball that? No, so we're going to work out manually later. Do you think we will have a y-intercept? Yes. Yeah. Guys, remember, this graph starts somewhere over here, right? Off the grid. Just because I'm giving you a 10 by 10 doesn't mean it's going to eventually go down and out. So right now, we don't know what it is. We will have to work out later manually. What is the domain of this function? All reals. So x and y-intercept will save it. Is this function a 1-to-1? Yes. What is the range of this function? All reals. Is this function an increasing function or a decreasing function? Increase. So right away you go to decrease and write NA. It's increasing starting at where? Negative infinity, and it ends at where? Positive infinity. How about the rate of change? It varies. So the two things we would have to work out manually would be the x-intercept and y-intercept, and that's the same for all x and y-intercepts. X-intercepts when y goes to what? 0. So x int, y equals to 0. So 0 equals 1/2 times x minus 4 to the third plus 3. Our job is to solve for what? X. First thing, what do? Subtract 3 from both sides. So if I subtract 3 from both sides, I now have -3 equals 1/2 times the quantity of x minus 4 to the third. Next, what do? Divide by half. What's another way of divide by half? Multiply each side by 2. Right. What's 2 times -3? -6 equals, what's 2 times 1/2? 1. So that's gone. Would you guys agree? Great. Now, again, I need to solve for x, but x is being bounded by the power of 3. So how do we undo power of 3? Cube root is right. Now, this is the part where I'm going to show you how to get the exact answer, and then I'm going to teach you how to use a calculator to get the decimal. Power of 3 and cube root, they will undo each other. Are you guys okay with that? So on the right side, you have x minus 4 left. On the left side, you just have third root of what? -6. Okay. Now, last step, we are going to add 4 to both sides. And then that's the exact, and then I'm going to teach you how to use a calculator to give me the decimal as well. So this is going to be 4 plus third root of -6. Okay. Here's how we use our calculator. I'm going to come around. I'm going to tell the graphing calculator people first. So if you have a graphing calculator, can you please enter in 4 plus? Okay, graphing calculator is 4 plus. Can you see there's a math button? Hit math. Can you see there's a third root button in there? Go down and enter. And then
enter in -6 in our case. And then, okay, non-graphing calculator, scientific calculator, ready?
Yes.
All scientific. Get it ready. Can you guys see a non-scientific calculator? Can you see there's a button that says X and then root?
Yeah.
Okay, this is the button I want you to locate. All right, that's okay. I don't want you to press anything. That's why you guys have error. Okay, shh. All I want you to, shh. Guys, all I want you to find it. Don't press the button because you don't know what to press. Okay, find this button. Ready? Scientific people, you found the button? Now, I would like for you to enter in this way. You're still going to enter 4. You will still going to enter plus. Now, because it's the third root, okay, it's the third root, your job is to enter 3 and then second that button. It will bring up this button like that. Your calculator will not do it unless you tell the calculator it's what root? 3. That's why you put the 3 first and then bring up that button. Then type in -6. Now compare the answer with everyone in your team. See if you have the right decimal. No, everybody. Who does not know how to use a calculator? I don't know how to use a calculator.
No, not mine. Dude, that's like.
I don't know what it is, but you got it? I don't know French. Not the -6, -6. And those letters everybody's phone and then all
I mean, no.
No, I know, like, it's only for, like, I should
Okay. You guys doing okay? You guys doing okay with calculator? Brandon, help me how to enter that in. You kids okay with the calculator? You guys okay with the calculator?
But I know she.
Oh my gosh,
No, I can go ahead and type in the answer. Let's say number 4. Because we're practicing our Why did you not get it checked over? There you go. I did.
All right. Calculator. Shh. What did your calculator, Lisa, give you? Your calculator.
I rounded it to 2.2.
2.2? Okay. Shh. Let's get back to the notes, please. Boys and girls. Okay. Alyssa said 2.2. If you have 2.18, that's okay too. So that's going to go in our replace of the x-intercept. 2.18 comma 0. The y-intercept, we have to solve that manually. So y-intercept is when x equals to what? Right. This one's a lot easier to solve. So here we go. I'm going to write y-intercept over here. Y int x equals to 0. Y equals, it was a half in the front. 0 minus 4 raised to the third power plus 3. 0 minus 4 is what, Kyler?
0 minus 4 is -4.
Good. Negative 4 to the third, Diego. What is it? Negative 64. Devin, was half a negative 64?
32.
Negative 32. What's negative 32 plus 3 later? Good. Class, can you guys see why we do not see the y-intercept on our graph? Because it's all the way down to negative 29. That's why it's not graphed on our paper. Okay. Example 3. A, H, and K. Ben, what are those?
Oh, A is -1.
Mm-hmm.
H is -2. And
Beautiful.
K is -3.
Good job. Okay. Emily, what is the parent function for our example 3? Y equals what? Thank you. All right, Kyler, give me the 5 outputs for the parent.
-8, -1, 0, 1, and 8.
Beautiful. All right, we are going to transform this. Oh, you know what I forget, for example? Oh, I did the transformation. I thought I forgot. Okay, A being -1, that will get multiplied to Y. H, negative 2, that's a left, so we are going to subtract it from x. Okay. K is negative 3, we will subtract it from y because those are the y transform. Take 1 minute, class, to transform both inputs and output. Go, 1 minute.
If you are all done, then plot it. If you are done plotting, then fill out the table.
Yeah. No, negative 3 cubic is not 1.
Oh, you're leaving Christmas Day for.
Yeah. You have a plus 2, minus 2. You have to subtract it.
Was that your guys' like Christmas present?
All right.
Chris, give me the 5 inputs. Thank you. 5 outputs. Jake, 5 outputs, hon. Shh. Boys, girls, I can't hear Jake.
5, negative 2, negative 3, negative 4, negative 11.
Negative what?
11.
Someone confirm that before I plot?
Yeah.
Okay. All right, negative 4, go positive 5. 2, 4, 5. Negative 3 is now negative 2. Negative 2 is negative 3. Okay. I'm just going to make one extra grid for the negative 11. Perfect. Transformations, we have 3 dots. 1, 2, and 3. The negative A, Kenzie, is what? State that for me. So the negative A value, what kind of transformation is that? Over, not y-axis, best. Good. Okay. Next question. Negative 2 for H, hun. What kind of transformation is that?
Shift 2 units to the left.
Good. Shift 2 unit to the left. A K value of a negative 3, Sophia. See, what transformation is that? K, negative 3, what type of transformation is that?
Downgraded.
Good. Okay. Okay. H and K, we know that was a negative 2, negative 3. The range for this question, Riley, is what, hon? Good. X-intercept, you will have 1, but we can't eyeball that, so we're going to work that out by hand later. Y-intercept, Mariana, we should know exactly where that is. Where's the y-intercept? Good. So 0, negative 11, perfect. Domain for this one, Autumn, is what? Good. Chris, right now. 1 to 1 or not, Karis? Good. Is this function, carefully, Santana, an increasing function or a decreasing function? Good. That means increasing, y'all. Right, NA. Decreasing, Santana, from where to where?
Is it negative?
Right. Okay. The rate of change, Malin, what would you write for the rate of change? Ooh, that's stairs.
And these are your announcements. Stand up, Miss Blake.
Buy your tickets. Permission slips are available at the front desk. Library
Brian?
and on htoilers.com. Reminder, you may not add a guest later, so ask your friends now. A huge congratulations to the girls tennis players, Caitlin Taylor and Sydney Will. Caitlin was chosen as the Daily Tennis Player of the Year, as well as OC Registrar's Orange County Player of the Year. Caitlin won the Wave League Singles title this year and was undefeated in the team play.
Guys, I'm quietly working on the X intercept for you, so write it in.
Sydney was elected to the first team singles after finishing fourth in the individual league.
Do you like artistic thrillers and Italian absurd? This Wednesday and Thursday, our 10-minute play festival will be performed at 7 p.m. in our Black Box Theater. There will be 8 world premiere plays written by our students, including comedy, drama, western, rom-com, and horror. Tickets are $5 for students, and it will be available at the door. Seating is limited.
HBHS Wrestling crushes it again, taking 5th place at the John Glenn Tournament. Congratulations to Hayden Hernandez, 1st place, Rod Mendhall, and Blake DeCourcy. 2nd place, Maris Fayette. 5th place, and Nolan Lord, and Luke Helgeson was 7th place. Great job, Oilers. Well, Oilers, these have been your morning announcements. Remember, stay cozy.
Someone use your calculator and give me that approximation, please.
Going down, 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 down. So that's why it's only a decrease. Right. Decrease and increase. You always go right to left. I'm sorry, left to right. So look at not particular functions. Every dot you move to the right. Is the y increasing? That means is it getting higher and higher, or the y getting lower and lower? Oh, right. Right. So that means that function is not increasing. Okay, practice your calculator skill.
Negative 3.44. Someone?
If you haven't or you don't know how to use your cube third root button, now would be the time for you to practice it.
Negative 3. One more time. 3.44. Megan, did you practice using your calculator?
Yes.
Okay. What did you get?
I got negative 2.44.
Good job. And that is